Hello, good morning. Xaru kameras, please. Mela. Ħankomplu mill-ewwel minn fejn ħallejna, alright? Mela. Yesterday I was talking about the two main different types of satellites. Let me remind you a little bit. So, we talked about what are called low Earth orbit satellites, satellites which are very close to the Earth. And actually, to calculate the velocity and periodic time of these satellites, we can assume, attenti għal kelma li qed ngħid, we can assume that the radius of these satellites is approximately the radius of the Earth because they are very close to the surface of the Earth. And we found that the velocity that we need to give them is 8 kilometers per second, and the periodic time, therefore, it's about 1.5 hours. On the other hand, geostationary satellites, which are satellites which have exactly the periodic time of the rotation of the Earth, 24 hours, therefore they will seem stationary from an Earth-based location. They should be placed very far away from the Earth, 36,000 kilometers above the surface of the Earth, and their velocity should be only 3.1 only. It's a very large velocity, 3.1 kilometers per second. And we were talking about the uses of these satellites. We said that for low Earth orbit satellites, in most cases, since these satellites are very, very close to the Earth, we use them for scientific reasons, weather prediction, to take photographs of the weather, of the clouds, spy satellites. We also have telescopes, and we also have the International Space Station in a low Earth orbit position. Together with scientific satellites, I can also write here, because yesterday I forgot, we also have photographic satellites. So when you look at Google Earth and you see all those photographs from space, all those photographic satellites, they are actually in low Earth orbit satellites. They can't be far away from the Earth, or else they can't take high resolution photographs. Those are very high resolution photographs. We can also, today they have an error of about, they can resolve up to 1 meter. We have photo satellites which can resolve up to 1 meter. Ġviri, jek tkompli tkabbar ir-ritratt tista' tara sa 1 meter ċar. Alright, infatti li hemm fuq Google Earth huma tajbin ħafna. One last thing, because this is something which is becoming much more common in low Earth orbit satellites, we are also placing satellites in this orbit very close to the Earth, satellites to provide mobile and internet connection. Is your mobile and your internet that you're using right now, they are definitely not satellite internet, satellite mobile, or else they will be much more expensive. The service is much more expensive. We managed to have internet and mobile, alright, communication in a country by using antennas which are placed around the country. Alright? Ġveri jek tkunu qed timxu, you will see antennas on roofs of certain buildings. These are very long antennas. Those are the antennas which transmit information between our mobiles. Okay? And the internet connection, I think you know, practically all Malta, now we have fiber optics. Internet is transmitted between our households using fiber optics, and then we have cables between Malta and Europe, and therefore we are actually connected using wires. So actually that is how we have internet. But the problem is that in areas where you are far away from cities, for example in jungles, in the desert, whatever, in the middle of the sea, you can't have internet and mobile connections. Therefore, what they are doing is they are placing satellites close to the Earth, and they have to be an array of satellites. Ġifieri ma jistax ikollok satellite wieħed jew tnejn, imma jkollok ħafna satelliti. Why? Because in low Earth orbit, when you have satellites in low Earth orbit, as we said yesterday, these satellites, they move with respect to the Earth. Infatti, satellita fl-low Earth orbit, jekk inti tkun qed tħares lejn is-sema, satellite fl-low Earth orbit kemm iddum? 2 minutes u tkun diġà krossjat is-sema ta' qudiemek għax they are very very fast. 8 kilometers per second għadna. Ġifieri within 2 minutes, 3 minutes ikun għadda minn qudiemek. Now, in order to have mobile connection to a satellite or internet connection to a satellite, you need therefore a lot of satellites, such that in every instant in time you have at least 3 satellites in the region above you. Għedin niftehmu, għajli dejni. Iviva nafna. Alright? Ġviri, you need a lot of satellites. And this constellation of satellites, they are becoming common because our devices, before it was very rare and it was very expensive, but as we are going along, we are inventing devices at a lower cost which can actually communicate directly with a satellite. Alright? Infatti, għaw il-mobile satellites jużaw ħafna l-militari, ħafna drabi, fej il-mobile jkun daqsxejn kbira, ovvjament l-antenna trid taqbad ma' satellita. Ġieli jkollhom anke diġ żgħir biex kun jistgħu jaqbdu. Il-militari jużaw ħafna fejn inti taqbad dirett mas sistema ta' satelliti biex inti tkun tista' tuża l-mobile anywhere. U l-internet ukoll miexi u bħalissa hemm xi żewġ kumpaniji, naħseb l-iktar kumpanija bħalissa famuża hija Starlink li hija parti minn ta' Elon Musk li għandu SpaceX, etc. fejn qed jitfa' mijiet ta' satelliti sanorikom, mijiet ta' satelliti biex l-internet ikun jista' jasal kull imkien. Ġifieri min qed jixtri l-kit biex jaqbad mal-Starlink system, jixtri dish, l-antenna bid-dish, alright, jaqbadha fuq il-bejt u inti taqbad dirett mem. Okay? Ovvjament hemm kost u l-kost mhuwiex irħis għax inti qed taqbad dirett, imma li għandek tajjeb huwa l-idea hija li inti tkun fejn tkun jista' jkollok internet. Ġifieri mhux bil-forsi rid ikollok internet service provider li qed iġiblek il-fiber optics għad-dar bħalma qegħdin. Malta m'għandniex bżonn assolutament għax Malta żgħira u l-fiber optic wasal kull imkien. Alright? Imma postijiet li huma barra minn Malta li huma kbar ħafna, hemm ċertu postijiet biex jasallek il-kejbil f'post remot ħafna tiġi tiswa ma jagħmlu ilekx, imma bidil mod tista' jkollok l-internet, etc. xorta. Issa, down the satellites, they are placed in low Earth orbit because they are very close to the Earth. And internet and mobile, you need to communicate very, very, very fast. You can't use satellites which are very far away from the Earth because else there will be a lag. Issa, il-lag, hawnhekk qed nitkellmu speed of light. But the lag, because the signal has to go to the satellite, then from a satellite it relays to another satellite, and then goes to the other one, hemm daqsxejn distanza mhux ħażin. Jiġifieri, jekk inti jkollok lag imqar ta' 20 seconds, alright, immaġina tibda titkellem fuq il-mobile u trid toqgħod tistenna 20 seconds sakemm jisimgħek. Jitkellem trid tistenna 20 seconds sakemm tisma' inti. Jiġi lag ta' 40 seconds. Hekk ma tistax tużah il-mobile, trid toqgħod tistenna minuta biex tisma'. Għalhekk dawn is-satellites qed jintefgħu fl-low Earth orbit, imma minn hawnhekk nimxu għal geostationary satellites. Mela, geostationary satellites għal xiex jintużaw. Geostationary satellites are mostly used, and they have already been used for a number of years now, for TV communication, mostly. TV communication. Jiġifieri, to transmit, to broadcast TV from one country to another. Sa ċertu punt, intom ma tiftakrux issa żgur. Ma jien meta kont żgħir, kont daqsxejn żgħar minnkom għax imbagħad meta kont daqskom kienu diġà bdew jinbidlu l-affarijiet. It-television aħna konna l-aerial mhux bħalma għandna issa tal-go, dik hija ħaġa differenti ħafna. Kien ikollna l-aerial u konna naqbdu biss l-istazzjonijiet ta' viċin tagħna, ġifieri ta' Malta, u meta t-temp ikun tajjeb nintolbu ħanna naqbdu xi ħaġa mill-Italja. Full stop, dak kien it-television, għax huwa li stajna naqbdu bl-aerial mill-area ta' madwarna. Full stop. Daqshekk. Ma kellna xejn channels iktar, imma x'għamlu il-geostationary satellites li għamlu hekk. L-idea hija din. So, if you have the Earth and you have a geostationary orbit, all right? Therefore, certain companies were actually launching an array of satellites in a geostationary orbit. Okay? Ġifieri kollhom array. U l-ismijiet tagħhom minn forsi jgħat għandu satellita xissa naqset ħafna, ma minn forsi jgħat għandu satellita l-ismijiet huma famużi għandek l-Astra per eżempju, alright, li huma kumpaniji li tefaw is-satelliti hemm. And therefore, if you have a TV station in this region of the Earth, how can this TV station broadcast to all the Earth? Mela, the TV station has a parabolic antenna, passoltu, and transmits microwaves to the satellite which is closest to that station. Issa, since these are in geostationary satellites, if a satellite is at a certain position, you will find that satellite at that position throughout the whole day. It doesn't move with respect to the Earth, għax tinsewx għandha periodic time bħal tad-dinja. Ġifieri dan il-connection ħatibqa' hemm 24 hours. Alright? Now, this satellite does two things. It transmits the information to the nearby satellites, and each satellite beams that information to the area of the Earth in front of it, and then relays the information. Therefore, this devastation from this position of the Earth, it can be actually broadcast using this array of satellites to the whole surface of the Earth. And then what we did was, every household could have a parabolic antenna as well on the roof. You can place your parabolic antenna, for example, at this position, pointing towards the geostationary satellite which is closest to you, and therefore all the TV stations which are being broadcast to that array of satellites, you can actually see those TV stations. Infatti, il-kumpaniji li għanna Malta, ħansemmihom għax m'għandniex għandna tnej biss, il-Go u l-Melita, kif jagħmlu biex jagħtuna l-istazzjonijiet kollha tat-television li naraw. Actually, they have very large stations where they can receive information of TV stations from these geostationary satellites. Li naf żgur fejna hija tal-Melita tal-Madlina. Hemmhekk il-fuq ħafna viċin il-Gargur. Alright? In fact, they have very large antenna dishes, kbar ħafna, alright? And they are pointing, and they have a set because they are pointing towards different arrays of these satellites. They gather all the information with a very high quality, għax għandhom antennas kbar għara jiġbru ħafna microwaves, and then they transmit everything using their cable, fiber optics, etc. Ġifieri, il-Go u l-Melita dak li għamlu. Alright, jiġbru kollox u mbagħad huma jittrażmettu bil-cables. Flok kulħadd għandu satellita fuq il-bejt. Alright? Ma naħseb hawn minnkom li għad għandhom satellita fuq il-bejt. Qabel konna nintużaw. Fimna kif taħdem dis-sistema tajjeb li tkunu tafuha. Ġifieri, il-geostationary satellites jintuża għal TV communication. Issa, tgħidilx għax ma nużawx dawn għal mobile ukoll. Ma nistgħux għax dan ikollok lag, għax is-satelliti huma ħafna l-bogħod mid-dinja. Għal sakemm jasal l-informazzjoni jasal lura, ħajkun hemm lag. Infatti tajjeb għat-TV stations, għax it-TV station ma jimpurtax jekk tara kollox ftit tard, ma tagħmilx differenza. Imma għal mobile, internet, etc. iva jagħmel differenza. Fimna hawnhekk? Alright? Issa. L-aħħar ħaġa f'geostationary satellites ġieli nsibu wkoll special type of weather satellites. Dawn ikunu weather satellites. Billi dawn din il-bot, they actually, when they take a photograph of the whole Earth which is in front of them practically. And therefore they can use these photographs to monitor the Earth as a whole system. Alright? Ġifieri mhux just on Europe biss jew on America biss, qed nitkellem jieħdu prattikament ir-ritratt ħarranti għandek 24-hour footage ta' kif qed jiċċaqalqu l-sħab etc. on a large section of the Earth as a whole. Ġifieri l-iktar biex jimonitorjaw klima iktar billi jagħmlu forecast biex jaraw il-klima kif qed tinbidel minn żmien għal żmien. Mhumiex daqshekk famużi ma jeżistu wkoll. Mela, qabel ma nibdew naħdmu xi ħaġa fuq satellites issa, li ħanagħmel huwa ħanurikom għandi din l-app tajba ħafna wkoll. Di turi d-dinja kif qiegħda bħalissa, infatti qed taraw ukoll id-dawl u l-lejl fejn qiegħed. Tarawux? Iva. U li ħanagħmel huwa ħanibda nurikom fejn qegħdin is-satelliti. Alright, issa ovvjament is-satelliti hawnhekk ħajkunu daqsxejn kbar. Alright, they are much larger than they actually are. Alright, ovvjament biex nkunu nistgħu naraw. U ħanibda bl-iktar naħseb satelliti famużi li jeżistu li huma daw it-tnejn. Alright, dawn qegħdin fl-low Earth orbit satellite, hawnhekk għandi l-International Space Station diġà urejtkom. Ma mhux hekk irrid, mhux passes hekk. L-International Space Station diġà urejtkom ukoll modell tagħha, alright, dik hija l-pożizzjoni tagħha fejn qiegħda bħalissa. U dan huwa il-Hubble Space Telescope li huwa l-iktar teleskop famuż li għandna sissa. Alright? Dawn huma l-pożizzjonijiet tagħhom kif qed tarawhom qegħdin flow Earth orbit, they are very close. Issa, dawn huma li qed nagħmilkom issa dawn huma kollha scientific satellites, dawn qegħdin kollha jieħdu informazzjoni fuq il-klima, etc. Jekk nurikom ħantella daqsxejn esaġerajt. Dawn huma l-orbits tagħhom kif qed iduru madwar id-dinja, kif qed taraw nużaw orbits id-dawra kollha, ma kif qed taraw ħafna mis-scientific satellites innotawhom jgħaddu minn fuq il-poles qed tarawhom il-polar orbit li semmejtilkom. Tarawhom ħafna minn daw is-satelliti jarawhom li huma scientific satellites kollha jgħaddu minn fuq il-poles. Tarawhom biex ikunu għax inti jkollok satellita waħda biex within one day prattikament tkun ikkaverjat id-dinja kollha u tkun tista' tieħu l-informazzjoni fuqha kollha. Issa, ħanibda nurikom issa ftit satelliti li nużaw kif għattilkom għal mobile u internet communication. Alright? U kif ħataraw ħajibdew iżidu, ġifieri dan pereżempju, jekk inneħħijek, dan huwa array wieħed tarawhom ta' satelliti li jintużaw for communication purposes, għal mobile purposes, etc. Jekk inkompli nżid dan huwa grupp ieħor, di li għattilkom bħalissa dawn huma l-Starlink. Alright? Li hija xi ħaġa ġdida ħafna ġifieri daw bdew jitellawhom fl-orbit madwar id-dinja bejn wieħed u ieħor daw l-aħħar sentej. Alright? U l-idea hi to have internet everywhere around the earth. Qed tarawhom. Huma satelliti żgħar ħafna, dawk huma, they are very, very small satellites, but the idea is to cover the whole earth. Hemm ukoll question marks fuqha x'anke tittellef l-astronomers, etc. Xaġa interessanti jekk qed tarawhom hemm gruppi ta' satelliti jisom qegħdin f'linja dritta għaliex meta jitilgħu daw jitellawhom 60-60. Ara meta jitellaw 60 jkunu bunch u mbagħad bil-mod il-mod jibdew jisseparaw ruhom ftit. U mbagħad jieħdu l-pożizzjoni tagħhom kif suppost. Dawn huma l-Starlink u baqgħu jitellaw. Pereżempju il-ġimgħa għandhom jitellaw ftit iktar infatti. Alright? Din hi l-idea biex ikun hemm kif għattilkom x'ismu ma' kullimkien. Issa, mela dawk huma low Earth orbit satellites. Jekk nixalhom f'salt, tibdew tindunaw x'inhi l-problema tas-satelliti madwar id-dinja. Innutaw x'hemm tas-satelliti jduru. Ġifieri importanti ħafna li jkun hemm laws u jeżistu laws internazzjonali fejn għandek titfa' satellita kif u kome u meta tellaħħa. Imma importanti li nimxu magħhom għax kif qed taraw l-ammont ta' satelliti li hemm madwar id-dinja huma ħafna. Tinsewx, huma ħafna iktar żgħar minn daw. Pereżempju dawk il-Starlink satellites li għattilkom huma vera żgħar. Ġifieri mhumiex fil-verità jikkaverjaw id-dinja hekk. Imma tittoqgħod attenta x'alla ħares waħda tidħol ġol oħra, tinsewx daw mixin at 8 km/s. Issa, ħanit fil-low Earth orbit satellites u ħanixal il-geostationary satellites u mill-ewwel tindunaw bid-differenza. Alright, il-geostationary satellites kif qed tarawhom il-maġġor parti tagħhom qegħdin on the equator, they are much further away from the Earth, okay? Again, mhux qiegħed to scale eżatt id-distanza, but they are much further away from the Earth, u kif qed taraw, they don't tagħtux każ daw, għax daw għandhom geostationary imma qegħdin at an angle. Daw l-importanti li qegħdin geostationary kif suppost. Kif qed taraw, they are in line with their point on the Earth and they don't change that position with respect to the Earth. They don't change their position. Iduru kemm iduru, jekk dik qed tippunta fuq dik il-punt ħatibqa' dejjem hemmhekk. Alright? Dawk huma il-geostationary satellites. U jekk taraw l-ismijiet tagħhom, hawnhekk, pereżempju, dak li kont qed ngħid daw wara fejn marru. Daw l-Astra min kellu il-satellita, min kien juża s-satellita dirett biex jaqbad magħhom, l-asra huma pereżempju grupp ta' TV stations qegħdin kollha hemm. Hemm l-Sky għandhom is-sistema tagħhom ukoll, hemm ħafna li għandhom sistemi tagħhom. Issa, l-aħħar tip ta' satelliti li ħan nitkellem fuqhom ma semmejthomkom ftit fin-noti, imma mhux ħanoqogħdu naħdmu affarijiet fuqhom, imma jista' jtikom jekk trid għax il-formula żemmeni. Huma the satellites that we use for GPS, for Global Positioning System, therefore to locate the position of your device. All right? And these satellites huma qegħdin at this orbit. As you can see, the orbit of these satellites, they are not low Earth orbit and they are not geostationary. They are in between, about 20,000 kilometers above the surface of the Earth. These satellites, in fact, they have a periodic time of 12 hours. Therefore, each satellite rotates twice around the surface of the Earth every day. Now, what are GPS satellites? GPS satellites are satellites which broadcast towards the Earth all the time, continuously, their position and the time. Their position and the time. Therefore, if you have your device, your mobile device, and your mobile device can communicate with at least 3 of them, receive information from at least 3 of these satellites, therefore the mobile can calculate, ngħidu la triangulation, it can calculate its position. Għaliex għax hekk taf fejn idi, u qed tieħu l-informazzjoni mela allura taf fejn hu l-mobile tiegħek. Therefore, in order for your mobile to be able to calculate the position where it is, it should at least communicate with 3 of these satellites, 3 of them. Alright? Infatti għalhekk meta l-mobile ikun id-dar u tippruvaw taraw fejn qegħdin bil-Google Maps, pereżempju, iħallilek ċirku kbir blu. Għaliex? Għax ma jkunx jista' jsib il-pożizzjoni eżatt, għax ikun qed jikkomunika mit-twieqi prattikament għax mill-ġebel ma jistgħux jgħaddu l-microwaves. Ara ħajkun qed jikkomunika pereżempju ma' satellita waħda jew 2. Kif imma toħroġ barra dak iċ-ċirku blu, bum, jiġi f'postu. Għaliex għax hemmhekk imbagħad tkun qed taqbad ma' 3-4 satelliti ra tista' ssib il-pożizzjoni tiegħek ħafna iktar preċiżament. And that is why there are so many satellites, because at each instant of time, anywhere in the Earth, you need at least to have 3 satellites orbiting above you. All right? Issa. A Global Positioning System is an American system. Obviously, it was devised in the 60s, jekk minn is-sejjer żball, bdiet mis-60s għas-70s bdiet, and the idea was for military purposes, as usual. All right? For military to be able to locate their position even if they are very far away from other systems. Ma żmien bdiet tintuża għal kulħadd li qiegħda fil-mobiles mhix xi ħaġa ta' malajr, ġifieri l-aħħar darba li kont qed nistudja jiena li kien fi 2009-2010 dak iż-żmien kelli device li kien jaqbad mal-GPS kellu biċċa ta' antenna daqshekk biex jaqbad. Alright, il-mobiles waqqas idea li jaqbdu mal-GPS. Alright? Ġifieri hija xi ħaġa tal-lum li t-teknoloġija tant timxiet il-qudiem li llum għandna prattikament nistgħu naqbdu ma' daw is-satelliti anywhere fuq il-mobile devices kollha li għandna. Issa, l-Ewropa qed tagħmel diġà bdiet mxiet ħafna l-qudiem qed tagħmel GPS system tagħha li jisimha Galileo. Li hija dik, kif qed taraw għadhom qed itellgħu satelliti, tellgħu ħafna imma għadhom qed itellgħu. Ġifieri prattikament dawn huma s-satelliti kollha tal-GPS issa. L-idea li l-Ewropa tagħmel tagħha ovvjament biex ma tkunx toqgħod biss fuq l-Amerika. Jekk xi darba l-aħħar isqat ikollna xi ngħidu mal-Amerika, inkella aħna nispiċċaw mingħajr GPS. Ġifieri importanti li jkun hemm iktar minn sistema waħda tal-GPS. Dawn kif tafu huma importanti ħafna. Ġifieri kif qed taraw jeżistu ħafna satelliti, artificial satellites iduru madwar id-dinja. All right? U f'dawn ir-regions kollha. Okay? M'għandniex ħafna satelliti li mhumiex qegħdin f'dawn it-3 regions partikolari. All right? Biss jeżistu ta' satelliti li jmorru l-bot mid-dinja mbagħad jerġgħu jersqu viċin, għandna minnhom imma vera ftit. Il-maġġor parti huma dawn li qed taraw hawnhekk. Okay, sissa, tajjeb, fimna xi ħaġa saw. Issa, qabel ma nkompli, qabel ma nibdew naħdmu id-domanda, ħanurikom video żgħir biex nurikom x'għandna bżonn biex intellaw satellita fl-ispazju. Dili ħanurikom ġrat il-ġimgħa l-oħra, diġà semmejtilkom, meta tellajna 4 astronauti fl-International Space Station. Mela ħanurikom x'namlu biex intellaw, ġifieri din hija l-istess bħal daqs kieku qed titella satellita, l-istess ħaġa. Ġifieri x'namlu biex intellaw mela satellita 1, 2 kif jiddokkjaw ma l-International Space Station u ħataraw anke l-International Space Station. U mbagħad ħanaraw ħaġa li rrid nitkellem fuqha biex nkun ikkonkludejt il-parti tas-satelliti. Mela hawnhekk insomma dawn tilajn ħanipprova naġġel ftit. All right. Mela, dan huwa r-rocket, kif qed taraw huwa simili ħafna l-dali għandi hawnhekk jiena. Mela, għandek il-lift-off bħalissa ħajibda jintuża l-first stage, mela dan kollu. U xogħlu biex itella din is-satellita barra mill-atmosfera, ġifieri dan hemmhekk għandek 9 engines pratikament qed jaħdmu 9 rocket engines u dawn qed jaħdmu kollox biex jaħdmu kontra l-air resistance li hemm. Dan il-first stage għadu kemm tela issa inqala u ħanaqilbu issa fuq is-second stage. U din hija l-engine tas-second stage kif qed taraw anke minn hawnhekk mill-ritratti bħalissa ħareġ mill-atmosfera, mela l-first stage biex joħroġ mill-atmosfera. Second stage to give the velocity to this satellite, 8 kilometers per second, and to insert it in the right orbit ukoll. Ġifieri on the left hand side hemmhekk qed taraw l-engine, on the right hand side dak huwa il-first stage nieżel lura lejn id-dinja. Dil-kumpanija SpaceX kienu l-ewwel kumpanija u s'issa għadhom l-unika kumpanija, hemm kumpanija oħra tipprova, that they actually recovered the first stage. Normally il-first stage bl-engines kollox jintrema, jinħaraq fl-atmosfera u jaqa' biċċiet fid-dinja. Emerja fil-baħar fejn dejjem jaqa'. Imma SpaceX irnexxielhom din l-stage terġa' tinżel u tillendja. Allura qed jiffrankaw ħafna flus għax mhux kull darba jridu jagħmluha, u infatti jagħmlu rivoluzzjoni sħiħa fi space travel għax il-cost naqas ħafna. Għax ovvjament dejjem jintuża. Immaġina inti kull darba li tasal bl-ajruplan tarmi l-ajruplan. Hekk konna qed nagħmlu. All right? Ġifieri b'dis-sistema inti qed iżżomm il-hardware kollu. Jiġi refurbished imma jiżżomm il-hardware kollu. Mela, issa ħataraw l-aħħar parti ġifieri meta s-second stage tinqala minn ma x'ismu hawnhekk qed taraw il-first stage reġa' l-Lendja. In-naħa l-oħra l-astronauti qegħdin fil-capsule, din il-capsule, u hawnhekk inqalat, ġifieri ġiet eżatt bħal m'għandi hawnhekk. All right? Ġifieri inqalat. Issa dik ġiet bħal satellita, kieku kellna satellita normali kienet tibqa' ddur normali hemmhekk. All right? Issa daw id-differenza ovvjament they have to dock to the International Space Station. Li hija kif għattilkom naħseb l-iktar station, l-iktar satellita importanti. Hawnhekk qed taraw jidher li m'għandux gravity fuq u din hija li ħanitkellmu fuq ftit ieħor. All right? Dik hija l-feeling of weightlessness. Weightlessness. All right? Issa nitkellmu ftit iktar il-qudiem fuqha. Mela, daw ġasset juru capsule. Issa, din hija l-International Space Station minn ġewwa. Ġifieri hawnhekk hawn l-astronauti li qegħdin fl-International Space Station. They are waiting for these astronauts to dock. Din hija il-vehicle li ġejja, all right? And it has now to dock with the International Space Station. Ġifieri dik ġejja jimmonitorjaw kollox għax importanti l-monitoring f'daw l-affarijiet. Ħajkolli nħalli ħaddej għax inkella m'għandix fejn. Din hija l-International Space Station qed jarawha għax ovvjament risqin fin-nofs hemm id-docking port. Qabel id-docking kien isir manually kollu b'joystick u jafsu l-lum sar isir kollox computers, kollox waħdu automatic. L-astronauti jislu jekk jinqala xi ħaġa biss. U hemmhekk għandek id-docking. All right? Issa dik tiddokkja tagħla totali u l-astronauti jkunu jistgħu allura jidħlu fl-International Space Station. Daw kienu għamlu xi xarejn sejjer żball. U hawnhekk qed tarawhom dan dejjem il-vehicle għall-International. Kif qed tarawhom hemm l-idea ta' weightlessness. Weightlessness ma jfissirx tibda tiflowti għal fuq bħall-ilma, Ġifieri jekk ma tagħmel xejn tibqa' fl-istess post. All right? imma m'hemmx bżonn imissu mal-art, kif qed tarawhom m'hemmx bżonn imissu mal-art, m'hemm xejn qisu li qed jiġbidhom biex imissu mal-art. Okay? Mela, ħan nitkellmu ftit fuq weightlessness issa. Għax din hija xi ħaġa importanti ħafna li tridu tkunu tafuha. Mela, weightlessness. So, when you have a satellite which is orbiting the Earth, all right? When we see those astronauts, they are actually as if they are floating. We say that they are weightless. So we say that they don't have any gravity acting on them. But is it true or not? Mela, let's try to think about it. When you have a vehicle which is going around the Earth, there is a gravitational force. If there wasn't the gravitational force, it would not circle around in a circular motion, ux vera. Biex ikollok circular motion għandek il-gravity. Infatti aħna għadna li for a satellite, and this was the most important thing actually, for a satellite, the gravitational force is actually the centripetal force. So actually there is a gravitational force, and the matter of fact is that actually this gravitational force in those lower orbits, it's not so different from the surface of the Earth. In fact, the gravitational field strength at the surface of the Earth is 9.81 newtons per kilogram. The gravitational field strength in those orbits, jekk nużaw il-formula G, the mass of the Earth over the radius squared, and we put exactly the radius of the lower orbits, meta taħdima, jekk tipprova taħdima, tiġi xi 8 newtons per kilogram. So actually, naqqas, tiġi iktar viċin, xi 8.7 newtons per kilogram, xi ħaġa. So in actual fact, the gravitational pull in those lower orbit satellites, actually it's very, very close to the gravitational pull that we experience here on Earth. So how it is that they seem as if they are floating, and actually they feel that they are weightless as well. They feel that they are weightless. In fact, astronauts, when they stay in the International Space Station for about, for example, 6 months, right? They have, there is actually an effect on their body, all right? Ikollhom problema fil-pressjoni tad-dem, fil-muscles, fil-bones, kollox jiġi affettwat. Infatti jridu jagħmlu training kull jum biex huma jibqgħu fit għax inkella jinżlu fid-dinja u jiġu jisom ġelli fil-veru sens tal-kelma. Ġifieri, verament iħossuhom weightless huma, but let's remember something. The gravitational pull that we actually feel, that we observe, is due to the reaction force, tiftakru? Dija minnija. The apparent weight that we feel on ourselves is according to the reaction force, according to how the ground is pushing you back. And if I try to draw the forces on the astronaut in the space vehicle and try to work out exactly as we did in centripetal force, in circular motion, araw kif ħanamlu, mela. Let's say that this astronaut is touching the ground, so the forces we have on him, they are the weight, because there is a weight there on him, and mg dashed, ħansemmiħ mg dashed, qed nsejjaħlu g dashed because we're not on the surface of the Earth, it's a little bit smaller. And there's the reaction as usual. But this astronaut, he's orbiting around the Earth, so he's a satellite. When you have these astronauts inside the International Space Station, if it is orbiting, everything in the space station is orbiting as well. So they are satellites. Therefore, since he is a satellite, he's orbiting around, therefore we are obeying Newton's second law here, because he's performing a circular motion. So F equals ma. Alright? A is v squared on r because it's circular motion, so it's a centripetal acceleration. And F is the centripetal force, is the force which is making these astronauts go around in an orbit around the Earth. And usually we write the resultant force towards the center, here we have the center of the Earth, as mg dashed minus r, vera. Mux hekk nagħmluhom f'centripetal circular motion, forces towards the center positive, forces away from the center negative. So mg dashed minus r is mv squared on r. So let's check how large is r on these astronauts. Look, mv squared on r is the centripetal force, but we said that for a satellite, the centripetal force is all provided by the gravitational force, is equal to the gravitational force acting on it. Therefore, mv squared on r is actually mg dashed, the gravitational force acting on the person. Therefore, r, jekk mg dashed neħħieħ in-naħa l-oħra u l-r jinġi n-naħa l-oħra, therefore r is 0 newtons. Therefore, that's why the astronauts will feel as if they are weightless, because the reaction on them is 0. If the reaction on them is 0, actually, they can opt not to touch the ground. Because if they don't touch the ground, since the reaction force is 0, if they don't touch the ground, the only force on them is the weight. There is no reaction, so this astronaut and this astronaut, they have exactly the same weight. So they have exactly the centripetal force needed, so both astronauts, if they are touching or not, they will still continue on orbiting around this station. So it doesn't make any difference if they touch the ground or not, because the reaction is 0 on them, they don't need it. Issa, the idea that the reaction is 0, it's obvious. Why? Because all their weight is being used as the centripetal force. All their weight is being used to change their velocity. Remember, they are moving at 8 kilometers per second. It's a very, very high velocity. So the gravitational force is just being used to change their direction only. Therefore, there is no part of this force which is pulling them down on the surface of the station. Moreover, the station has exactly the same thing. It is accelerating towards the Earth exactly as the astronaut. So this is very, very similar to the question that we had of the lift. Tiftakruha? If the lift is accelerating down with the acceleration due to gravity, it is falling freely. In that case, again, the person in the lift had the weight and the reaction again was 0 newtons. And in fact, he could actually float in the lift, tiftakruha? Alright? Imma mbagħad kontattilkom. But then they will realize that actually both the lift and the person, they are accelerating towards the Earth when they reach the ground, because then they will smash with the ground. Alright? It's just a feeling that you are weightless, but in real fact, they are accelerating towards the ground. Therefore, these astronauts inside the space station, can we actually understand the situation as if they are falling towards the ground? Yes, they are falling towards the ground all the time. Look, in fact, they are falling freely towards the ground. In fact, they have the weight, vera. When they are going around, actually, look, if I draw a line, a straight line, this is if there was no force on them. But actually, they are moving around the Earth. So look, they are actually falling towards the ground continuously. Look, if this is the line in a straight line, but in order to move in an orbit, in fact, they are falling towards the ground. So actually, when you have a satellite orbiting, it is falling freely towards the ground all the time. Because if there were no gravity, they would move in a straight line. Therefore, in order to move towards the Earth all the time, they are actually falling towards the ground. But they have such a large horizontal velocity, 8 kilometers per second, that if they fall 1 meter, the surface of the Earth is falling 1 meter as well, due to the curvature. That's why we need to give them exactly 8 kilometers per second. And in that manner, if they fall 1 meter, the surface of the Earth is falling 1 meter, actually they will keep their altitude above the surface of the Earth. But in actual fact, astronauts in a space station orbiting the Earth and a person in a lift falling freely towards the Earth, the physics is exactly the same. In both cases, the vehicle and the person, both of them, they are falling freely towards Earth, they are accelerating freely towards Earth. The only difference is that in a lift, it doesn't have a horizontal velocity, so they will fall towards the ground. In an orbit, they are falling towards the Earth, but they have such a large horizontal velocity that they will never reach the surface of the Earth and they will keep always the same altitude. But it's exactly the same thing. So when you see these astronauts floating, it is not in fact because they are weightless, only because all their gravitational pull is being used as a centripetal force. Alright? Therefore, the reaction force on them is zero, so they don't need to touch the surface of the spacecraft, and therefore they will feel as if they are weightless. In fact, in space terms, we're not using weightlessness anymore. We're using the word microgravity. Alright? We say that they are in microgravity. Għax jekk ngħidu they are weightless, actually we are not correct with respect to physics. Ara llum il-ġurnata jgħidu they are in microgravity, ġifier they are in a gravity which is smaller, imma mbagħad ovvjament dan kollu ifisser. Attenti għax tridu tkunu tafuha. Alright? In most cases you are asked about this part of apparent weightlessness. U għandkom kollox qiegħed f'section 6.1.4. Għandkom kollox hawn dak kollu li għamilna issa. Alright, mela, morru page 19, ħanaħdmu id-domanda fuq satellites. Alright, mela. ħanaqrawa l-ewwel, imbagħad x'ismu. Mela, find the mass of the sun, given that the distance between the Earth and the sun is 1.5 times 10 to the 11 meters, and that the Earth takes 1 year to complete one orbit around the sun. In fact, this is interesting because this is how we actually know how heavy the planets and our star is. Alright? We measure the mass of these planets not by actually measuring the mass, we can't do it, but instead by observing the periodic time, knowing the distance. How do we know the distance from us to the star or from us to a planet or something like this? By comparing the intensity. We know that the intensity, the brightness, decreases with the inverse square law. And therefore, by comparing the brightness, which that's and using certain graphs, etc., we can actually calculate the distance, we can actually theoretically calculate the distances between us and those bodies. Alright? Mela. Ejja ħanibdew naħdmu l-ewwel waħda. Therefore, we have the sun and we have the earth. The distance between the center of the sun and the center of the earth is 1.5 times 10 to the 11 meters. Alright? That's the distance between the sun and the earth. And the periodic time of the earth around the sun, so the earth is a satellite of the sun, mhux vera? The periodic time is 1 year. And we have to find the mass of the sun. So, let's call the mass of the earth small m. Mela, kif ħanibdew naħdmu? As soon as you have a question regarding satellites, so the earth is a satellite of the sun, and you're given the periodic time, so it's about satellites for sure. As soon as you know that you're talking about satellites, immediately write down, therefore the gravitational force is all being used as the centripetal force. Kif taraw satellite, din trid tidħol f'moħħkom mill-ewwel. Satellite, the gravitational force is used as the centripetal force mill-ewwel. So I have G, din il-formula ta' gravitational force. Gm, the mass of the sun on the radius squared, is equal to mv squared on r. Obviously here I'm using small m because it's the earth which is performing circular motion. So the centripetal force is acting on the earth. So the mass of the earth cancels out. Therefore the mass of the sun is equal to v squared times r squared on r all over g. Mhux hekk tiġi? Taqblu miegħi sissa. Sissa, right? So the mass of the sun is equal to v squared jaqta jiġi r on g. Now, the problem is that I don't have the velocity. I don't have the velocity of the earth moving around the sun. We have r, g is a constant, but we don't have the velocity. But we have the periodic time. And we can find the velocity from the periodic time. How? Because the velocity is the change in displacement over the change in time. If the time is the periodic time, what is the distance traveled in one periodic time? What is it called? Circumference. 2 pi r. Di jaqbdu tal-muwa ta' velocity hija 2 pi r on t, on the periodic time, because we use it a lot. Therefore, I'm going to put all this instead of v. Mela ħajkolli 2 pi r on t squared times r on g. Mela ħatiġi 4 għax irrid niskwerja pi squared r squared times r over t squared times g. Mela ħatiġina 4 pi squared r cubed over t squared g. The mass of the sun. Let's work it out. Mela għandna 4 pi squared. The radius is 1.5 times 10 to the 11 cubed, or over the periodic time. Now, the periodic time is 1 year. How many days do we have in 1 year? Isa. Le, mux eżatt. Xkont għattilkom fil-bidu tas-sena? 365.25, tinsewhomx. Times 24 hours, times 60 minutes, times 60 seconds. Squared, il-laħwar għazbaqa li post. Times g, and g is 6.67 times 10 to the minus 11. That's given. Mela, ħanitfa kollox fil-calculator u naħdimha. Mela għandna 4 pi squared times 1.5 to the 11 cubed over 365.25 times 24 times 3600 mill-ewwel, everything squared, times 6.67 to the minus 11. That's it. And the answer is, the mass of the sun is 2 times 10 to the 30 kilograms. This is how, in actual fact, we find the mass of planets, stars, etc. Alright? Now, let's move to the second part, which is very similar. Similarly, find the mass of the Earth, given that the distance between the Earth and the Moon is 4 times 10 to the 8 meters, and that the Moon takes 28 days to complete one orbit around the Sun. So actually now we have exactly the same idea, but now we have the Moon, which is orbiting around the Earth. Okay? So I'm going to use actually the same formula, because if we derive it, it's the same exactly formula. So, but in this time, the object in the middle is the Earth, so the mass of the Earth is going to be equal to 4 pi squared r cubed, where r is the distance between the Moon and the Earth, which is 4 times 10 to the 8 meters, alright, over the periodic time times g. Mela, ħanamel l-istess ħaġa. Mela 4 pi squared r is 4 times 10 to the 8 cubed over the periodic time. Now we have 28 days times 24 times 60 all squared times g, 6.67 times 10 to the minus 11. So it's exactly the same, but we changed the distance and the periodic time. Now I'm going to change the distance. So the distance is 4 to the power of 8. And I'm going to change the periodic time. And now it's 28 days. And the answer is 6.4, answer 6.5, times 10 to the 24 kilograms. And that's the mass of the Earth. In fact, this is the way how even Newton calculated most probably the mass of the Earth. Alright? This is how we actually calculate the mass of planets. If you have a planet and there's a moon going around, if you calculate the periodic time, if you observe the periodic time of that moon, from the periodic time of that moon, and by calculating the distance between the two objects, you can actually find the mass of the planet or the star around which the satellites are orbiting. Alright? Ġifiri, meta jkollkom satellites, l-iktar ħaġa importanti hija, as soon as you know that you have a satellite, immediately write down gravitational pull is equal to the centripetal force. That's the most important thing. Write that immediately and then you can start working. Alright? Imma dik mill-ewwel iksbu GMM on R squared equals MV squared on R u jitilqu minn hemmhekk. Mela. Sarinna l-ħin ħani qafaw għax issa minn għada ħanibda biċċa xogħol ġdida. Just biex nafżakom ftit, please. Friday, next Friday, għandi appuntament ma nistax nitilfu jiena u sirt naf bih dal-aħħar. Issa, ħabba li għedin lej l-aħħar, eccetera, mhux ħanitilfilkom il-lesson. Ħanamlilkom eżatt bħalma għamlittilkom il-ġimgħa l-oħra meta kelli mura l-vaccine. Alright, ħalli ma nitlifx. Ġifieri ħan nirrekordja l-lezzjoni u nagħmililkom available biex tkunu tistgħu tarawha. Please tarawha. Għaliex jekk ma tarawiex, u mbagħad it-tlieta ma tkunux tistgħu taqbdu x'inkunu għamilna. Alright? Importanti ħalli nibqgħu għaddejjin bil-pass li qegħdin tajjeb ħalli sal-aħħar nkunu lessejna definitely kollox li għandna bżonn għall-aħħar tas-sena. Alright? Għax ma nixtieqx nitfakom laqqa sezzjoni lura jekk jista' jkun. Okay? Tajjeb? Fimna? Ħallejtkom hawnhekk, narakom għadha. Ciao ciao.
Thank you, sir.
Ciao.